Hi, this is Mr. Kier. In this video, we're going to be looking at electronegativity and the formation of ionic bonds. I just want to review what electronegativity is. That's the relative attraction for two elements for bonding electrons. So the bigger the electronegativity, the more an atom will want to attract those bonding electrons. Now what we do is we look at the two elements and we look at the difference in electronegativity between them. And when the difference in electronegativity is very small, that means that both elements like electrons evenly, relatively evenly, and as a result, they share those bonding electrons fairly evenly, and they form a nonpolar covalent bond. There's no charge overall for the compound. Now, when the difference in electronegativity is a little bit larger, what that means is that one of the elements has greater attraction for the bonding electrons than the other. And as a result, those bonding electrons tend to spend more time on the side of the element with greater electronegativity. This means that the electrons are there more, that there's a little bit of a negative charge. So we call this charge on this side a partial negative charge. And on the other side, the electrons aren't spending as much time here. This then becomes slightly positively charged. So we call that a partial positive charge. And again, this is because of the uneven sharing of electrons. Now, if the difference in electronegativity is so high, what happens is the element with the greater electronegativity simply attracts and holds on to the electron, and it becomes an anion. And the other element with the lower electronegativity becomes a cation. So there's a true transfer of electrons, no sharing, and you get these true charges being formed here. And that's what we're going to be looking at today. Oh. So what you have in your workbook is this little note, and we're going to be looking at an example before I actually copy the note down. So what I have here is magnesium chloride. Now magnesium chloride is a metal, non-metal. Grade 9 and 10, you said, okay, metal, non-metal forms ionic bonds. Well, let's make sure. So what you do is you look up the electronegativity of magnesium, and you have the chart on your back of your periodic table. So magnesium has an electronegativity of 1.3, and chlorine has an electronegativity of 3.2. And you don't double up because you have two chlorines. You just look at one chlorine, for example here, the value of the electronegativity. Then what we do is we're going to be looking at the difference in electronegativity. So the difference in electronegativity here is going to be 1.9. And what that means is, according to our chart over here, we're bigger than 1.7. We're somewhere over here. So that means that we're going to be forming an ionic bond, exactly what we expected. So that means that there's going to be a transfer of electrons or bonding electrons from the magnesium to the chlorine, from the element with the smaller electronegativity to the element with the larger electronegativity over here. So these electrons here, these bonding electrons, will be transferred over. So one of the bonding electrons is going to end up over here at the chlorine. The other bonding electron from magnesium is going to end up with this other chlorine. So we have this transfer of electrons. Oops, sorry. Transfer of electrons. And because we have this transfer of electrons, so this electron is going to be here, this bonding electron is going to be over here, magnesium has become stable, but in the process, it's lost 2 electrons and it has become charged. So it has a charge of 2 positive. And each of the chlorines has picked up 1 electron, so each chlorine has a charge of 1 negative. So what we have here is we've got these cations and anions, and the ionic bond is actually the attraction between, between the anions and cations. So this in here would be the ionic bond. So you're not sharing electrons in this bond. This bond is simply due to the opposite charges attracting each other. And what you did last year, or when we did nomenclature, we did the crossover method. You would end up with this. You had magnesium. It can form ions with charge of 2 positive. Chlorine forms ion 1 negative. And what we ended up doing was crossing over, and you end up with this formula, magnesium chloride. And that's exactly what we have in this ionic compound. So what you're going to do now is you're going to go to your workbook and you're going to be practicing drawing ionic bonds with the Lewis dot diagrams. You're going to show how the electrons are being transferred from the anion, or say cation, to the anion. So I want you to show the transfer, and then I want you to show the formula and the final ions that are present there, the cation here and the anion. So do that for this workbook page. And you can check the answers online. And that's it for this video.